Hi everyone, welcome back to our channel. Today we are going to study about the steady state analysis of an series RC circuit. So how the reactance triangle, voltage triangle and impedance triangle we are going to construct in series RC circuit. We are going to learn in this derivation. Okay, so let us try to see here. We are having an resistor and a capacitor which are connected in series excited with an instantaneous voltage. So this instantaneous voltage we are going to write down small v is equal to V maximum sine of omega t minus 0 degrees, and this is the resistance, and this inductor we are going to write down it as minus j xc ohms, and the current we are going to get it as small I. This instantaneous current we are going to get it as maximum current into sine of omega t. We are going to get plus 5. Okay, here 5 will be 90. Okay, so what is this steady state analysis, what we are going to get? So see here, let us try to understand. Since it is an AC supply, we should not mark the polarities. In order to apply the KVL, I am marking the polarities. So the voltage drop across the resistor is VR, the voltage drop across the capacitor is VC, and the total applied voltage is V. So in order to link all these three voltages, I am going to apply KVL, which is nothing but Kirchhoff's voltage law inside the loop. So when you apply the Kirchhoff's voltage law inside the loop, this is nothing but plus V, and this is nothing but minus VR, and this is nothing but minus VC is equal to 0. Therefore, we can write down V is equal to VR plus VC. So how to write down this V is equal to, how to write down voltage across the resistor is current into resistor. This I can write down I into R. How to write down the voltage across this point is, so I into minus J XC ohms. So here I can write down this as I into Z is equal to, I is taken as common, which is R minus J XC ohms. Therefore, I will get cancelled. The total amount of impedance is R minus J XC ohms. So from here I can write down Z in terms this impedance, which is in rectangular form. I want in polar form. This I can write down as root of R square plus XC whole square. And 5 we are going to get tan inverse of imaginary part. What is imaginary part? XC by R minus XC by R. So this is the total impedance offered. And now we need to draw the diagram for this. Okay, so how to draw the diagram is V is equal to VR plus VC. So where this is not a normal addition, this is an vectorial addition. So first I am going to draw VR. Okay, so I am drawing the VR with an angle of 0. This is VR at an angle of 0 volts. And now we want to draw VC. So how to draw VC? So VC is equal to I into R. R is minus J XC ohms. This I can write down I into XC. What is the angle we are going to get here? Minus 90. So if it is plus 90, then we want to rotate in counterclockwise direction. If it is minus side theta, then you write down in clockwise direction. What is the angle we got here? Minus 90. Minus 90 means you should come downwards, okay, which is nothing but a clockwise direction. So this counterclockwise direction, we are going to take it as positive, which is a reference direction. So therefore, we are going to get XC at an angle of 90. So with respect to VR, we try to draw an angle. So with an angle of how much? Minus 90 degrees. Then we are going to get VC. So therefore, the vector addition. Okay. So this is the magnitude of VR, and this is the direction. So this is the magnitude of VC, where the magnitude of VC is I into minus JXC. This is I into R. So Here we are going to get V, where I can write down small v is equal to the vector addition of the voltage across the resistor plus the voltage across the capacitor. So we got ultimate V. So from here we need to draw the voltage triangle as well as reactance triangle as well as the power triangle. So here, in order to draw the voltage triangle, let us try to mark this angle as an phi. Therefore, from the diagram we can write down sine phi as well as the cos phi. So sine phi is nothing but opposite side. What is opposite side? So opposite side is VC divided by hypotenuse. Hypotenuse is V. So next one is cos phi. So cos phi is equal to, this is opposite side. What is 90 degrees to the opposite? Which is nothing but adjacent side. This adjacent side we are going to write down VR divided by V. So from here the voltage across the capacitor we can write down VC is equal to V sine phi. The voltage across the resistor is equal to V cos phi. So this I can write down it as V cos phi, and this I can write down it as V sin phi. So from these two diagrams I can call this as an horizontal component of voltage, or V cos phi is called horizontal component of voltage. This is called, which is in 90 degrees, vertical component of voltage. This is vertical component of voltage. Now we got horizontal component as well as the vertical component. So from this component we need to get the impedance triangle. So this triangle I am going to call it as voltage triangle. So this is the voltage triangle of the given network. From the voltage triangle we need to get the reactance triangle, okay, or we can require the impedance triangle. So how to get the impedance triangle from the given voltage triangle? Okay, so divide this with 1 by a. It's nothing but V by I we are going to get as Z, which is called impedance triangle. So here you can see here, this is I into R divided by I, then you are going to get the horizontal is R, and divide the by I, then you are going to get minus JXC. This is at an angle of minus JXC, and you are going to get the total impedance is Z. Therefore, Z is equal to R minus JXC. So this is the total impedance offered by the triangle with an angle of phi. So next we need to get the total power triangle from the voltage triangle and these two triangles. Okay, so now let's try to draw the power triangle. So this is the given power triangle. So from power triangle, so this voltage triangle is multiplied into I times. So V into I cos phi. Okay. So the horizontal component of power we are going to call it as V I cos phi, where this is called active power. Okay. So here we are going to get V sin phi, multiply this with I, then we are going to get a component in downward, where this is called reactive power. This is V I sin phi, and the vector addition of P plus P minus JQ we are going to get it as S. The formula for S is V into I. Therefore, S is equal to P minus JQ. Okay, so here we are going to get with an angle of minus 90.